In this section, we'll build a package that simulates data storage for users. In a real app, we'd probably have a data source that this API would reference. That might be a database, or another API, or combination of things. For this, let's stub in an example package. First, we'll create an internal folder. This tells Go that these packages aren't to be referenced by anybody who's not a sibling of this folder. For instance, main. Inside of internal, we'll create the package folder itself. Let's call this one users. Inside of users, we create the Go file. And you'll note that my IDE has named the package users because that's what folder it's in. Let's also create a test file. In the same way as before, we'll name it the package being tested _test.go. And we'll put it over here. Now let's create the type. We'll call it user. For properties, let's mimic the idea of a real user here by giving it a first name, a last name, and an email property. Note that email is a mail.address. You also might have noticed that this struct is very similar to the idea of a user data struct, but with more fields. Having similar structs like this in two different packages does necessitate a certain amount of conversion, but I personally think it's worthwhile, because it allows you to more easily hide data or combine data to suit the purposes of the API return values over and above the things that you want to store about a user. Later, you can add extra values, take them away, or combine them in different ways. This allows your API to serve responses to queries that it wasn't even originally designed for. And it also decouples the idea of the data being stored from the data being returned. Let's move this back. Because this is simulating something else, be that a database connection or a client of another API, we probably want to have a single instance of this object that interacts in the same way as a client would. Let's create a type for this as well. If we call this manager, it becomes easy to understand what this is, because when we consume it, the type will be users.manager. Inside this manager, let's just hold a list of users. Note that this is not exported. Now, we need a way to create an instance of this. Here's where you would normally do setup code, and you might take arguments if you wish to have the main package drive configuration. For this, we just need to return a pointer to a new manager. With that done, we need to think about how we get data into and out of this. Let's scaffold in a new function. In this case, we'll set this up as a method that takes a pointer to a manager. We'll name it addUser. And because it's adding a user, we need to think about the arguments needed. We could say that you need to provide me a user object, but I think it's easier if we just say that we want some strings in this case. Also, we'll need to return an error, because as we build this user, we'll need to validate that the information provided is indeed valid, and tell the caller if it's not. Because we're just scaffolding, let's go ahead and return a temporary error. Now let's write a test for adding a user. Firstly, we'll need a manager. Now, if we store all of our test parameters in variables, it'll be easier for us to validate it later. In this case, first name and last name are just strings. That's simple enough. But because we're going to have an email address ultimately stored in the user struct, here we've created one and we've used parse address. It should be noted that parse address performs a very, very basic validation of an email address. For instance, foo@bar would be a valid email address. This is because of the way mail.parseAddress works. If we look at the documentation, we can see that parseAddress parses a single RFC 5322 address. You can look that up if you like. But we can see here, somebody has already been confused by this. And they're saying that mail.parseAddress incorrectly parses email addresses without top-level domains. If we scroll down here, we can see it verified, that indeed, name@domain is a valid email address under the RFC 5322. And you can see also here referenced that the rule requiring a TLD comes from RFC 5321, which isn't part of the package's validation. This has been closed as not planned. Your validation needs may differ, so be aware of that. Next, let's try to add our user. We provide the parameters we just created, but we also call .string on the email. Also, if this errors, we need to consider it a test fatal error as well. There's no point in validating if this fails. Because we're inside of the same package, we can now examine the test manager directly to see what the results were. Let's first make sure that we have one user. We can also do a little trick here. This will cause the test to error if there are not one users in the list. However, we could still continue on and validate if there were more than one. If there weren't, we would need to fail. So we can just call fatal. Now we need to know what we're expecting. If we create a user struct and fill it with our test data, we can then use reflect deep equal to make sure that the structs are indeed equal. This is why we created all those variables up top to begin with. Also note that parseAddress returns a pointer to an email address object. We need to dereference that here because we're not storing a pointer. To make the syntax a little shorter and nicer, let's also say that testmanager.users at the 0 index is stored as found user. Now we can deep equal it. And here we need to output them in a meaningful manner. There is a compare package that would allow us to get a diff of these two objects, but that's not in the standard library, and using only the standard library is one of the constraints of this course, so we'll just use deep equal and output it manually. Here we'll add a new line for better visual spacing. And we'll use +v to also make it print the property names. Another new line. And one final new line. Now we should be ready to run this. Unsurprisingly, it fails. It's not implemented. Let's go ahead and go implement this now. Because we need to store a mail.address instead of a string, we know that we need to parse this email address in the same way we did in our test. Now that we parsed it, let's create a new user object. And we'll dereference the pointer just like before. Here's normally where you'd write the code that would store this object inside of whatever data store you're using. For us, we're just going to append it to the list. And we'll return nil in this case, as there are no errors. Now let's run our test again. As you can see, everything is passing. Let's go ahead and minimize this. Because we return an error in case of invalid email, we should probably test that as well. Let's go ahead and write that test. We'll call this test add user invalid email. For this, we'll still need a test manager. And let's also store some variables here. In this case, the email will just be a string. We're not doing this for any specific reason other than it'll look similar to our other tests, and it'll be easier to read because of that. Now, let's attempt to add our user with this bad email. Here we expect an error, so if we don't get one, we need to say that we didn't get one. But if we did get an error, we want to validate that it's the error we expect. Let's store that as a variable here, just to make the syntax nicer to use. Then we can compare the strings. And output a meaningful message. Lastly, let's validate that nothing got added to our test manager's list of users. And we also want an error message here. With that done, let's run our tests. And everything's passing. We correctly handled this case here. We'll go ahead and minimize this again. Okay, mini challenge time. What are the obvious things that we should validate here? Pause the video, take a look, and let me know what you think. Hopefully you were able to spot that we need to validate that our first and last name aren't empty. Now, as a challenge, go ahead and add tests that cover both of those cases. Pause the video now and give it a try. Okay, hopefully that wasn't too bad. Let's go ahead and do this together. So let's go ahead and create the test function. And we'll test an empty first name first. Now, we've already written a lot of the code that we need to make this test successful, so let's just borrow from ourselves. Up here, we can borrow this error check. We will be expecting an error still. From here, we can borrow our setup code, including the email parsing. And we also want this call to test manager add user. Now we need to make the test first name empty, like so. Let's go ahead and run this really quick. And you can see that we fail, as we expect. We do need to fix this though. The error message that we're going to get back is going to tell us that our first name is invalid, because this is an internal error. We can decide whether or not to expose that to the user in the consuming package. We'll say invalid first name. And then we'll want an empty quoted string. And we can use escape characters to create that. Now we also have everything we need to create a successful test for a last name. If we copy this and change the function name, then we can adjust the data. Down here, we'll also want to call out that we expect to say invalid last name. Let's run these both. And we can see they both fail, as expected. Let's go ahead and minimize this. And now, as a challenge, go ahead and check both of these parameters and then return the error messages that we just specified. We'll want them to return the actual entered first and last names. Go ahead and pause the video now and give that a try. Okay, that should have been pretty simple. Let's go ahead and do this together. If our first name is an empty string, then we'll return our error. And we can use the quoted string here. Same as last name. This is a very simple validation. In a real product, you might want to make sure that these don't contain banned words, like swear words or admin or something like that. You could also pull this out into a separate function that return things like a boolean or an error string or something like that. That way you could reuse it when you're trying to edit an entry or something like that. But for this simple example, this should be quite sufficient. Now, let's run our tests again to make sure that we've handled this correctly. And everything's green. Fantastic. Let's go ahead and minimize this again. Now that we have add user, we're also going to want a way to get a user out of a manager. Let's go ahead and scaffold that in. Now there's a lot of different ways that you can get a user. For this simple example, where we don't have any kind of unique identifier or anything like that, let's just do a by name. And we'll say that we want to be able to get the user that matches first and last name. We'll create that. This will return a pointer to a user. I like this because it allows me to nil check this pointer. And an error. Once again, we'll add our temporary placeholder error. And we'll go write some tests. Let's collapse these real quick. And let's add our function. Normally, I prefer to break my tests up, as we've been doing so far, with each individual permutation being its own test case. I'm prepared to accept duplicate code and tests. However, in cases like this, we want to have one object with a lot of data stored in it. We want to run a lot of different inputs through our function and examine the behaviors. So let's do a table-driven test for this one. We'll still need a new manager. And then we need to add some test users. We can use our add user function here. If we were to fail to add these users for any reason, we should halt the test here, so we'll make these fatal errors. Let's duplicate this code block because we're going to add a different user. We'll make this one bar Baz. And now let's duplicate this once more. We'll make this Foo-Baz. We're going to mix and match first and last names here. And one final copy-paste. This will be Baz Foo. Now let's set up our tests. For this, if we do a map with a string key and struct value, we'll be able to give our test names that'll give us nice output. We can create an anonymous struct here, and say that it has the properties first, last, expected, and expected error. And then immediately start populating it. We have a couple different permutations of tests that we probably want to do here. First and foremost, let's just do a simple lookup. We know that this exists. First and last are the properties that will feed into the getUsers function. And we expect to see a pointer to the first element of the current test manager users, because it will return us foobar. Expected error should be nil. Let's add another case. Let's make sure that we can get all the way through our list and find the last element. For this, we give the name of the last element. And we expect to see a pointer to the last element. And we expect no error. Next, let's make sure we handle an element that does not exist correctly. Because it doesn't exist, we'll probably expect nil. But here's an interesting question. What do we expect for an error? We could just return an error like we have done before, but how do we know if that's an error that means there were no results found, or if it's an error that means I wasn't able to talk to the database, my query timed out? Let's go over here really quick and create a sentinel error. This is just an errors.new, and we'll give it no results found as the text. Now, if we get an error back, we can check and see if it was an error, no results found, and we know that there were no results found, and we don't need to retry or do anything else. We can also use this in our test as the expected error to make sure it's correctly returned. With that done, let's go ahead and test a partial match lookup. Remember, we should only return if the first and last name both match. And we should expect error no results found as the error. Let's also make sure that if this is provided with an empty first and last name, we handle this correctly. In this case, let's just say that we silently handle this and return no matches. And we'll do the same for the last name. Now, we need to run through the tests. For this, we just range over our test map. Inside of here, we call our test manager getUser by name, and we provide it with the arguments from the test. Now, we can use deep equal to test the result like we've done before. If it's nil, we expect nil. We'll return a meaningful error message. First, we'll use the test name, and we'll also return the structs with line breaks like before. Lastly, we'll check that the error is correct. We'll use errors.is here. Then we'll create an error message here that's very similar. With this done, we should be able to run. And as you can see, all of our tests failed, as we expect. Let's go ahead and minimize this. And we'll start working on implementing this. We'll keep this one very simple. First, we'll range over the list of users in the manager. Then, we'll compare the first and last name that we were provided with the first and last name stored. If they equal, we'll return. Here, because we're returning a pointer, but we don't necessarily want anybody to mutate our user in our list, let's go ahead and make a copy. And then we can return a pointer to that. Otherwise, if we get through the entire list and don't have a match, we'll return nil and our sentinel error. Let's go ahead and run this test. And you can see all of our test cases already pass. If you're uncertain about this actually creating a copy, we're actually able to prove that really quickly because we exercise this function in our tests. Let's print out the address of the item in the list. Then, let's print out the address of the new variable. If we run our tests again, we can see that these addresses are not the same. We can take those back out, we don't actually need them. Now we're almost done with our placeholder package, but there is one thing. If we go back up to our add user method, we note that nothing actually prevents us from adding a duplicate name here. That might be a problem. As a challenge, go ahead and write a test that will cover this case. Pause the video now and give it a try. Hopefully that wasn't too hard. Let's go ahead and walk through creating that. We'll minimize this and tidy this up a little bit, and then we can add our new function. We'll call it test add user duplicate name. Now, we already have a lot of the code that we're going to need for this, so let's just go ahead and copy this. We'll need to change this to add our last name back in. It should be a valid user. And if we go back to our add user test, we can copy our fatal error here for failing to add the user for the first time. Now, we move that down a little bit. We call it again, and we're expecting an error again. Let's go ahead and tidy that up. And we might have also forgotten to change that here. Let's fix these while we're thinking about it. That'll help us if we get an error and need to debug them. Now, what should we return here? How about just a simple user with this name already exists. In a real system, we might want to return another sentinel error here to indicate whether or not this operation should be retried. But for our purposes, this will be fine. Also, we need to make sure that we're checking to have only one user in our test manager after adding. The first one should have succeeded. Make sure to also update the number we're expecting in the message. Now, let's go ahead and run these tests. And as you can see, duplicate name did not return an error. And we have 2 items in the list. This one might be a little bit more tricky, but as a challenge, if you feel up to it, go ahead and pause the video and try to fix this yourself. If you don't feel confident, then that's okay too. Okay, if you gave that a try on your own, that's awesome. And if not, no worries, we'll walk through it right now. So here, after we validated that our first and last name aren't empty, let's make sure that it doesn't exist yet. And we can use the function we just made. And give it the first and last names. Here, let's check our error. If we did get an error, and it's the Sentinel error, then everything's fine. But if it wasn't that, we want to raise a different error. So here we'll say if the error is not equal to nil, and it is not equal to error no results found, using errors.is, then we return a different kind of error. And we'll say error checking if user is already present. Now we can check if the existing user is nil or not. For this, we'll say if it's not nil, we return an error immediately. And we'll return the error string that we decided to look for in our test. Now, let's run our test once more. And as you can see, everything's passing. Let's minimize this. And now we can move on to the next section and start consuming this module. And that'll wrap up this section. Thank you very much for watching, and I hope you learned something. If you'd like to support me and help me to create more content like this, check the video description below for ways in which you can do that. You can also just share this video with your friends, and that'll help a lot too. Thank you very much again, and we'll see you in the next one.